Stop. Okay, let's look at this. It looks like to find our y-intercept, b, alright, we need to multiply our slope times an x value and subtract that quantity from the corresponding y value. Yeah, it's like math magic. We can do that. Okay, welcome. Well, let's talk about what we've got so far. We have done a lot of work here. Here's my main code. My three subroutines is first one gathers our two coordinates that define our line in a couple of lists. The next one is finding slope. It's where it computes, my second subroutine, computes the slope by subtracting the y values and reporting that, and subtracting the x values and reporting that. And then, actually, I guess it doesn't find the slope. It just finds the pieces of the slope. And then, finally, I have a subroutine that finds and reports the slope. My third subroutine, where it actually reports what the slope is going to be in fraction form, using the denotes it using m equals, and it uses it as a fraction, and then it computes the actual division and reports it in a decimal form. So now we have the slope, okay? So I guess really what we have left, the piece of our long-term goal here, is to write a program that's going to write the equation of a line in slope-intercept form. And so we've got the slope. Now we need to figure out a way to compute the intercept. So maybe we'd better talk about some math at this point. Okay? Today we're going to work on Scratch activity number 8, where we learn to find the y-intercept. We're going to talk about the math here, the math behind what we're doing. Alright, we've already learned how to gather the coordinates for the line that we want to graph and gather the information for, and from that we're learning to find the slope. And now we're going to talk about the y-intercept. Alright, so let's go from there. Alright, I'm going to get a piece of graph paper here, and I'm going to, let's see, is that all showing up? Yes. Alright, I'm going to put on a couple of points here for us to gather some information. Let's go put on the point 3, 6. So the x value is 3, 1, 2, 3. And the y value is 6, positive 6, up 6. 1, 2, 3, 4, 5, 6. So here's our point 3, comma 6. Our x and y coordinates. Next, I think negative 5, negative 5. Alright? So negative 5, 1, 2, 3, 4, 5 backwards, and down 5 into the third quadrant. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So here's our point, negative 5, negative 5. Is that showing up? Yes, it is. Alright, so this creates a line, and I'm going to use, hopefully this will work, because I didn't bring a ruler. I'm going to connect these points and create a line. Alright, there's our line defined by these 2 points. Okay, and so we are going to write an equation of our line in slope-intercept form. Alright, we know the slope of our line, the 2 points on our line, but where does it cross? It looks like it crosses about 2, but not quite. So I want to know exactly where it crosses and write that and use that in an equation. So So I'm going to use what's called the slope-intercept form. That's always been such an attractive way to write the equation of a line to me, because it's just easier for me, my brain, to understand the slope-intercept form. That's where we use the slope and the y-intercept to write our equation, to tell everybody what line I'm referring to. The slope-intercept form. Alright, and that looks like this. Y equals mx plus b. This is a very common, conventional form to write the equation of a line, where m is the slope, b is the y-intercept. Alright, so we're going to do that, and I better get my class to lunch. Okay, so back from lunch, and let's continue on trying to understand what it means to write the equation of a line in slope-intercept form. Well, we've already found the slope, the rise over run, the change in the y values versus the change in the x values. And we've calculated that to be 11 over 8, 11/8. And we know one of the points on our line, the x and y coordinates, are +3, +6. So now I'm going to find the y-intercept, where this line crosses, intersects, and intercepts the y-axis, using algebra. Algebra is a handy tool, so I'm going to substitute the values that I already know in for the variables that I know. So for example, I know one of the y values is 6. So I'm going to write 6 is equal to, now I know m is the slope, is 11/8, times the x value, which is 3, plus b, the y-intercept. Now that's what we want to know. So we're going to use algebra to solve this equation for b. We're going to isolate the variable b and combine all the rest of this garbage so that it tells us what b should be. So, all right, here we go. So let's see, what do I know that I can do? Well, I can multiply 11/8 times 3, which is 3 is 3 over 1. Of course, I hope you realize. So that's actually 33, 11 times 3. Okay, so I'm going to multiply the slope times the x value and get 33, 11 times 3 is 33, over 8. So I've got 6 equals 33/8 plus b. That's going to be our y-intercept. So we're going to isolate that variable. So let's see here. What can I do? I can subtract 33/8 from both sides of the equal sign. All right, using my algebra rules, so I'm going to subtract 33/8, and this is just the way I do it. And over here, I'll have 6 take away, 6 minus 33/8. Oops, 33/8. All right, plus b. Now, these 33/8 minus 33/8 is 0. And, excuse me. So we're left, those will kind of cancel out, as we say, as I say. And we're left with just b on this side of the equal sign. That's a good thing. And now 6 take away 33/8. I want to find a common denominator and convert that 6 over 1 to 8ths. So I'm going to multiply by, maybe 8 over 8? Sure. So 8 over 8 times 6 is going to give me 48/8. Take away 33/8. So I'm not writing this correctly. 33/8. My Sharpie is not sharp enough. And so there, I'm just going to subtract these two fractions. 48 eighths minus 33 eighths. Chunk, that's 15 eighths. So 15 eighths is our slope intercept. Now 15 eighths is 8 goes into 15 one time with 7 left over. So that's 1 7/8. That's our slope, our intercept. Let's look at our line. Oops. And yeah, see, it almost hit 2, but not quite. 1 7/8 is almost 2. So now we know the slope, and we know the y-intercept, where it hits the y-axis, is 1 7/8, or we'll just say 15/8. So, there we go. I'm going to turn this over. Let's get a new sheet of paper. And so we can write an equation of a line in y-intercept form. Y equals mx plus b. So we could say y equals 11 eighths x plus, what did I say? 15 eighths? 15 eighths plus 15 eighths, or 1 7/8. So now, what we have to do is write the code that will do all this math for us. Alright, so now we should have a better understanding of the slope and the y-intercept. And so, good luck with that. Thanks. Let me know if you have questions.
Okay, now let's create another subroutine, a block, that will calculate the y-intercept. So let's find the y-intercept. Alright, so, okay. Now we have to define it. So, oh gosh, but we have to make this work for Scratch. So we really need to understand the y-intercept portion of this. Perhaps a flashback to the little math lesson would be helpful. Yes, I remember it like it was just a few minutes ago. Doodle-doodle-doo, doodle-doodle-doo, doodle-doodle-doo,
So I'm going to
doodle-doodle-doo.
multiply the slope times the x value and get 33. 11 times 3 is 33 over 8. So I've got 6 equals 33 eighths plus b. That's going to be our y-intercept. So we're going to isolate that variable. So let's see here. What can I do? I can subtract 33 eighths from both sides of the equal sign.
Stop. Okay, let's look at this. It looks like to find our y-intercept, b, alright, we need to multiply our slope times an x value and subtract that quantity from the corresponding y value. Yeah, it's like math magic. We can do that. Doodle-doodle-doo, doodle-doodle-doo, doodle-doodle-doo. Okay, well, now that we've gone out of our my flashback sequence, what we need to do is incorporate this into our programming. Alright, I said that to find the y, in fact, let's make our, what do you call this guy? Sprite. Our sprites say that to find, alright, to calculate the y-intercept, we need to, and I think I'm going to make that worth 3 seconds and add some more. You know what? No, I'm not. I'm just going to keep the same one. We need to multiply the slope, right? The slope times, running out of the slope times an x value, and then subtract that. You know what, let's add another one because I don't want to keep going over here. And subtract that from a y value. Value. Did I spell that right? Okay. So let's see what that looks like. To calculate the y-intercept, we need to multiply. Oops, yeah. A little more time. Let's try 5 seconds. And this for 3. To calculate the y-intercept, we need to multiply the slope times an x value and subtract that from a y value. Okay, so we need to do that. And actually, I've kind of done that right here. So let's create a variable, and let's call it our y-intercept. Y-intercept. Okay, so I'm creating my y-intercept value. I guess I should add that in here to say, let me pull in some join things here. So we'll say, in other words, let's see here. Now, what are we going to do? We're going to multiply the slope. In other words, multiply. Now that we're going to take the slope, we're just going to take the decimal slope, multiply space the slope decimal, space times space, and now times a y value, right? So, or no, times an x value. So we're going to take an x value, let's choose x, it doesn't matter, let's choose the x1s and the y1s, times x1 so in other words, multiply whatever the slope is times whatever the x value is. And I'm going to need some more of these joins. Times, I guess our x1 is going to be 2, right, for this particular example, 2. Then we have to say minus, no, and subtract that, so, and subtract that, and subtract that from space, what's our, from our y value. So we used x1, so let's use y1, period. Alright, so throw that in there and make it say that for 6 seconds. Okay, here we go. So I hope you're following this. Let's see what he says over here. So to calculate the y-intercept, we need to multiply the slope times an x value and subtract that from a y value. In other words, multiply 1.5 times 2 and subtract that from 3. Okay. Or whatever we happen to put in there. So now we're going to take that y-intercept and we're going to set the y-intercept equal to y1 minus the slope times the x value, x1. Let's put that in there. Okay, so it will tell us. So if we put in here, in this case, our line, let's use the ones that we were using before, if I can remember that. I'm going to go ahead and find the y-intercept. So let's put in the points. So let's run this again, and let's use the same points that we did in our math lesson. So what is the coordinate for the first point? That was 3, and then the y was 6, so it was 3, 6, and then -5 and -5, right? Okay, so hey, it didn't clear those out. So now we'll compute the slope. The slope is defined as this. Let's determine the change in y, or the rise. So it puts those in there. One point is 3, 6. One point is 5, -5. First we need to subtract, or in other words, 6 minus -5, which was 11, right? And now the run was going to be 3 minus -5, which is going to be 8, right? If I remember correctly. Yes. Okay. So the slope was 11/8 or 1.5. It's already calculating it here. Slope is 11/8. M equals 11/8. And, or, oh wait, not 1.5, 1.375 in this case. Okay. To calculate the y-intercept, we multiply x this times 3 and subtract that from 6. Okay, and so it was going to be 1.875. Yeah. Slope. Yeah, the slope was 11/8, and the y-intercept was 1. 1 7/8, which is 1.875. Okay, so, alright, that works. So, alright, now, we need to, so we found the y-intercept, I guess we've done that, right? So, let's go ahead and report that out, finding and reporting. Let's have it tell us what the y-intercept is. Okay. So here we go. So the y-intercept for this particular line is ... and we'll say that for 3 seconds, and then we will have him say is, I guess we better get a join. I want it to say b, which is because that's our letter for y-intercept, equals, and we'll just say y-intercept. Let's go grab that y-intercept. Hold that for 5. Okay. Calculate the y-intercept, we need to multiply the slope times an x and subtract that from a y value. In other words, multiply, I'll need a space there, 1.375 times 3, and subtract that from 6. So the y-intercept for this particular line is b equals 1.875. Okay, that's pretty nice.
Hello, sir.
Hello.
Sorry.
Okay, so what I'm going to do now is I'm going to clean things up. I noticed that I spelled subtract wrong. You probably noticed that too. Subtract, oops. And also that I needed a space in here, I think it was. Alright, so let's take a look at that. To calculate the y-intercept, we need to multiply the slope times an x value and subtract that from a y value. In other words, multiply 1.375 times 3 and subtract that from 6. So the y-intercept for this particular line is b equals 1.875. That's pretty good. I think I would only say that this should probably go maybe 6 seconds. And I think I'm going to add in my comments that say that this subroutine, let's call it subroutine 4, subroutine 4, and I'm going to say this subroutine will compute, or calculate, let's use that, calculate and report the y-intercept using the coordinates input in subroutine number 1. Alright, that kind of explains that. One more time. So yeah, I just feel so smart when I do this. Okay, let's start that again. Stop. To calculate the y-intercept, we need to multiply the slope times an x value and subtract that from a y value. In other words, multiply 1.375 times 3 and subtract that from 6. So the y-intercept for this particular line is 1.875. Okay, now I think what I would like to see you do is not only calculate the y-intercept, calculate and report the y-intercept, but find a way to report the y-intercept as a fraction value. Okay, because that's using decimals, real numbers, decimals in this instance. It's not generally accepted to do that. I mean, it's legitimate, but it's just not usually done that way. You usually use fractions and integers. So I wonder if you could find a way to report the y-intercept out as a fraction, much like we did the slope back in our earlier subroutine, finding the slope here. How we reported that out in a fraction form. Okay. And another thing that would be impressive if you could figure out a way to do, think about that, is how could you input those values but also reduce those fractions to lowest terms. We just reduce the fractions. Something to think about. I'd like to to see you maybe brainstorm with your partners about that and see if you could come up with a way to do that. So I think I'm going to move this subroutine down below and call that good for this lesson. There's a lot to soak in here, and so feel free to watch this thing as many times as you need to. Ask questions. You know that I'll help you. You know that I encourage you to help one another. But what I really want to see is that you understand the programming behind this, and that I've helped you to understand the mathematics behind linear equations like this. What does the slope mean? What is the y-intercept? What is writing an equation in slope-intercept form mean? Because that will be our next lesson. Number 8 is writing the equation of this line. Okay? So thank you for listening to all this. So clean up your code, and let's see what you can do. I'm really impressed with you. Thanks so much.